A cereal company is redesigning its cereal boxes to make them stand out on the supermarket shelves. For some unknown reason, they went with a triangular prism for the shape of their box. The front and back are isosceles triangles with base 10 inches and height 12 inches. The surface area of the entire box is 384 square inches. What is the depth of the box? There's a lot of information here. We're going to start by just drawing a picture. So we've got a box and it's a triangular prism. Now a prism just means you take a two-dimensional shape and then kind of stretch it out in one direction. So we've got a triangle, and it says that they're isosceles triangles. So isosceles triangles are where we've got two sides that are equal in length. Okay, so these two lengths right here are equal, and we know that the base has 10 inches, okay, and the height is 12 inches. Now, this is one side of the box, but it's a triangular prism, so that means we're going to kind of extend it out, okay, and we get our box, okay. And so maybe I should go a little bit behind. We can kind of see, just so that we can kind of see that three-dimensional figure. So there's our box, and so we've labeled what we know, the base and the height. We also happen to know the total surface area of the box. That's 384. So we've got to figure out how to get the surface area of this thing. Now, for the surface area, notice that there's several different sides of this. Okay, there's 5 sides to this prism. We got the front and we've got the back, both of which are those isosceles triangles. We also have these edges here, these long strips that are rectangles. Okay, and so we're going to be able to add all the areas of those up to get the total surface area. So let's start with the front and the back. Okay, now both of those are isosceles triangles. And so for the front and the back, we get the area of the triangles. Well, the area of a triangle is 1/2 times base times height. Now the base is 10 and the height is 12. So this is 60, and that's just one side, that's one triangle. Okay, but there's 2 triangles. So the front and back is going to be double that. All right, so the area of the front and back is 2 times 60, which is 120. All right, now the depth of this box is the thing we don't know. I'm going to go ahead and just call that X. So that's this length right here, or that length right there, or that length right there, okay? And each of these rectangles, we can get the area of by doing length times width. Now we need to be careful because we don't actually know this length right here of that rectangle. We know the height of this box is 12 inches, but we don't know this length right here. So what we're going to do is look at this as kind of a right triangle. Okay, we've got a right triangle here, and the height is 12, and since 10 is the full length here, that means that half of that length, 5, is that base of that triangle. Okay, and I'm talking here about the this triangle that I've outlined in red. So I'm trying to find this length right here. I'm going to go ahead and call that C. And the reason I'm calling that C is because I've got a right triangle where A and B are the legs and C is the hypotenuse. So I can use the Pythagorean theorem to find C. A squared plus B squared equals C squared. So we have 25 plus 144 equals C squared. And 25 plus 144 is 169. And the square root of 169 is 13. So we get 13 for C, which is this length right here. 13. Now I can get the area of these things, which I'll call the edges. Area of the edges. Well, this edge right here, let's do that in blue. I'll just highlight that here in blue. This edge right here, okay, we do length times width for a rectangle. So that's 13 times x. 13 times x. But that's just one edge. This edge over here actually has the exact same area, okay, because this was an isosceles triangle. That also has a length there of 13. So we're going to take that and we're going to add another 13x to it. Okay. Now, the base down here, that is different. Okay, this, actually, let's do a different color there. That rectangle has a length of 10 and a width of x. So when I add that, I add 10x, and that is going to be the area of all these edges together. So now we're ready to put all of this together. The total surface area, the front and back was 120, plus, and then the edges were this right here. Now that's 26x plus 10x, which is 36x. And that all together, that's the total surface area, and we happen to know that that is 384. So equals 384. Now we can solve for x. If we subtract 120 from both sides, we get 36x equals 264. And then we need to divide both sides by 36. So x equals 264 over 36. That comes out to be 7 1/3, or 7.3 repeating. And that is the depth of the box. That's that x. And of course, we should put units on that. That's in inches. Everything we're doing here is in inches.